Welcome to Advent of Code 2023 Day 13. Today's puzzle is called Point of Incidence, and let's jump straight into it. This is the input file, or part of an input file for Day 13. It is a map. Now the map has two characters in it. They are empty spaces represented by dots, or rocks represented by hashes. And we're told in the puzzle description that somewhere in this map there is a mirror. A mirror exists either between two rows or two columns, and it reflects everything to the other side of it, as mirrors do. For example, in the input we just had a look at, the mirror existed between columns 5 and 6. You can see there that column 5 and 6 are a match, 4 and 7 are a match, and so on up to column 9. Anything beyond the edge of the map, we just ignore it. If we get matches left and right across a certain point, we consider that to be where the mirror is. Here's another example of an input file, this time with a horizontal mirror. You might be able to spot it. It sits here between rows 4 and 5, and you can see everything above the mirror matches everything below. Now, to get the answer to our puzzle, we need to come up with a score. For a horizontal mirror, the score is the number of columns to the left. For a vertical mirror, the other way around. For a vertical mirror, the score is the number of columns to the left. For a horizontal mirror, the score is the number of rows above multiplied by 100. We get a number of different maps. We need to calculate each score, sum them together, and give that as our final solution. To keep things simple, we only ever see one mirror in the input file, and it's either horizontal or vertical. Now let's get into the solution. In terms of data structures and algorithms, this is less complex than a number of the other puzzles that we come up against, but we do have one trick that makes it a little bit easier to solve. The high-level plan for the solution is to loop through each row or column, depending on how we're looking at it, and check backwards through each of the rows or columns that we've already seen. If we get a match, and we reach all the way to the end, we found a mirror. If not, then we keep searching. The only real shortcut I looked at here was storing the input files in two different formats. These two formats are described as row major format and column major format. You can see examples of a 3x3 grid here stored in each version. And the difference here is how they reside in memory, which we'll see in the code. For the row major version, we store 3 vectors of vectors that are 1, 2, 3, 4, 5, 6, 7, 8, 9 going across these rows. So we store each element in one vector for one row. Column major is the opposite. We have one vector for each column. So we'd have 1, 2, 3 going down, 4, 5, 6, 7, 8, 9 going down that way. This will make a little bit more sense when we have a look at the code, but it means that if we create a processing function, we can process them both the same way, one that just operates on a row major input or a column major input. Now, getting into the code, which as always is in a Git repository linked in the video description. Starting off, we do a couple of simple inputs, nothing too surprising there, and we define this structure called map, which stores 2 copies of a 2D vector of characters, one in row major format, one in column major format. We then define this function. Now this function takes a map. It doesn't know which direction it's stored in, and it doesn't matter. And it returns a number. If we find a mirror, that number is then the row or column, or the location in the map, I should say, where that reflection is found. If not, it returns a 0. So it says no reflection. The way we do it is we loop through each of the lines in the map. For row major, that's per row. For column major, that's per column. And we do a check. We say, hey, looking at all the lines that have come before, is there an identical match between the two lines? If there is, perfect, we found a match. There's some part 2 code, which we'll look at later. But if we get all the way to the end of the loop and we still have matches and we didn't find any mismatches, we say, cool, there's a mirror there. And if not, then we return 0. And the reason we need to return 0 is the mirror may be in the opposite orientation from the one that we just checked. Looking at the main body of the function, as usual, we read our input file into a string and we start to loop through. We loop through each of the different lines. If we find an empty line, we've reached the end of that current map and we throw it into our maps vector in both row and column major format. For row major format, we just parse the lines one by one. And in the process, we then push those values as we're reading them for that current row into the collection of columns. So that gives us those 2 row and column major formats that we saw in the earlier part of the video. After we've read the map in, we try and find, or we've read all the maps in, I should say, we try and find reflections. We first check the map in row major format. If we don't find a match there, we check the map in column major format. We know there's a mirror in either case, so one way or another we're going to end up with a score. If we found it in row major format, we multiply the row it was on by 100, add that to our score. If we don't, we will find it in the column sense and we just add that to the score. With that, we get our score for the given set of maps and we are done. That's the end of part 1. Looking at part 2, it says that, look, something in the maps that we were given is incorrect. There is exactly one hash or dot that is out of place. And by adjusting that and correcting it, we'll get a different mirror than we did before. So we need to adjust our checking function to account for that fact, but otherwise the rules are exactly the same. So looking at what's changed, it's just this else branch in our check reflections function. We now have to keep track of a Boolean value, which, as per the problem description, is a smudge, which, they say there's a smudge on the mirror that makes it look disoriented. And what we do to account for this is we check through the lines, and if the first time we see a mismatch, the difference between that line and what would have matched is exactly one character different, then we say, okay, we'll use up our smudge, we'll assume that was the smudge, and we'll continue processing as if it was a match, keeping note of the fact that we've already used up that one-off thing. If we get to the end, we then calculate the new position of our reflection. If we find a second mismatch, we just sort of reset that smudge and continue going. After that, we run this exact same code base with this additional else clause through there, and we get the new updated position of our mirrors, and that gives us the final answer for part 2 of this problem. So nice and quick one for today. Hopefully you found that interesting. If you did, do all that YouTube stuff, comment, subscribe, all of that good stuff. If there was anything you wanted answered in this, let me know in the comments below. Otherwise, I am Elliot, I build stuff, and I will see you in the next one.